This is project 2, video number 3, the one in which we put the finishing touches on the code and do the documentation for the code. I'll get to the editor here. One of the things we have to do is to title our plot. So I'll go title, and then this is position versus time. The x-axis title would be time in seconds. Remember to use square brackets here, not parentheses. Said so in the handout. So you have to get credit for the documentation part of the code, and the finishing touches, documentation and finishing touches part of the code. And then Y label position in meters. I'll save that and then see if it still runs. Plot XVT, plot X versus time. You can do it with no parentheses or with empty parentheses, since this that's wrong. I gotta put the velocity and the acceleration in there. So I'll go 10 meters per second starting, and let's say -2. I think that's really something like I used before. So now I got plot XVT, a MATLAB string. Looks like I left a closing quote off. This one. It was telling me that too. Look at the color of it. Okay, go save. Try it again. Now it's running. Did run. Gave me a graph. And that looks good, although I should probably put the time in capital letters. So axis title should be capitalized, unless you're using a symbol to represent it. And then run it again. Take a look. Position versus time. Position is here, time here, seconds, square brackets, meters, square brackets. Okay, I think the graph looks good. So let's get to documentation. Okay, so the first line, write a big long comment. Of what the code does. Let's say clearly state the situation. So we got a car at a start line. State that you should be talking about your variables in stating what it does. The algebraic signs of V0 and A must be different. They have to be different. Okay, and then say who it's by. Then input variables. Say what it is. So don't just say it's the initial velocity, say it's the initial velocity of the car, and hopefully the car has been described up here in your explanation of what the code is. Then we got percent A. Say what it is. Then output variables. And percent function turns no values, words to that effect. Let's see, we're going to need to give credit. Oops. Percent attribution. Say what you used for what. In other words, use video 2 to help me write the code, or hopefully some of you guys are saying, well, I looked up the MATLAB function plot on the internet. I just searched for MATLAB plot, those 2 words, and found out what it does, how to use it, and I also looked up linspace. I'm guessing title, X label, and Y label. You either browse through the function browser, or that you may have had to look at the video for. Look at video 3. Maybe you have to say, I looked at video 3 to figure out how to title the graph and the axes, that kind of thing. But say specifically what you use for what, not just I use Professor Schnick's videos. Be more detailed. Okay. Let's tell the reader what's going on here. Calculate might not be obvious based on the description what one is doing in this step. I think I'll do it as a comment at the end of the statement. So calculate time when car comes to rest. Alright, this, if anybody knows a little bit, it's pretty obvious what one is doing here. If I were to write something afterward, I would say create an array of time values from time 0 to time t sub s, or ts, where ts has already been defined. So, but I think it's straightforward what's happening there. And then x vals, I think that's pretty clear too. v0 times time plus 1/2 a times squared. If you know a little physics, you can see what's going on there. So this was the only one. It involves solving something on the pencil and paper. It's not a standard equation. Then we're titling the plot, so it's pretty obvious what we're doing there. So I think I've described those parts that might not be clear and obvious to the user. I think Just for mine. Yours is obviously going to be different. You have to actually write the explanation. Say, here's the given situation. We got a car at a start line, already moving when it's at the start line. It's got an acceleration. Both the initial velocity and acceleration are provided by the user. The user must make certain that the two values have opposite signs. And keep on going from there to say what the code does. Creating a graph of position versus time for this time to that time. Okay, I think I'm ready to go through the checklist. Pencil and paper part must have each of these parts. A complete algebraic solution, I did that. And an outline of the steps the program will execute, I did that. As for the program part, reasonable attempt at writing the program, I think I did that. One or more .m files, yep, I saved it as a .m file. Actually, this baby needs to be saved again. There we go. If it works properly, let's make sure, because I think I might have everything done. If I have to tweak on it some more, we'll try it again, but let's make sure it's still working for now. And see what the graph looks like. Okay, I think I'll leave it open so it comes up the same size, but let's try it with -50 and 2, so it's backing up rather fast. And yeah, look at that. It goes quite a ways backwards. Alright. So it is still working. Was it printing anything to the screen? Let's make sure. No, nothing came out. Nothing was printed to the command file. Okay. Must correctly do what it's supposed to do, so it makes a graph. And whenever the user results in nothing being printed to the command window. Well, I stipulated with a semicolon at the end, but in this case, nothing was being printed anyway, so it doesn't matter whether I had the semicolon there or not. So, yeah, with the semicolon, nothing's printed to the command window. One point for documentation and final touches, which is what this video is really about. You must have your name in every .m file. Jeffrey Schneck. This is the .m file. By the way, make sure this file name up to the .m is the same as your function name. Plot xvt, good. Your code must be documented for each function. That's all we have is one function, one .m file. A comment starting on the first line after the function. This is the very first line after the function statement. Stating what the function does, advising the user that the sign of the acceleration must be opposite. So don't forget to say this part. State. So you got to write the statement. Don't copy my words. Use your own words to make that statement, as well as say what the code does. Then we need another set of comments, providing a list of arguments of the function, the input variables. Here they are, VO and A. That's the list of arguments of the function. With, beside each argument, a statement of what that variable is. You got to say what it is. You got to say what it is. Make sure you do that. Your function should return no values. State in writing the fact that your function returns no values. Output variables, there are none. This function returns no values. That was pretty straightforward. This kind of tells the reader, even just looking at the first line of code, that it returns no values, and that I chose a name that tells the reader that it's not being used. You should do the same thing for all your variables and your function name. Don't say project2, for instance, as a function name. Say what it does. You can call it graph, position versus time. There's a million different names one could come up with that say what it does. These, same thing. You can call that initial velocity. That's a long variable name. It is a good idea to keep them short so the expressions don't get too long, but you could call that acceleration. Constant value of acceleration, that's really too long, but would probably work as well, as long as you follow the variable naming conventions, which it's got to start with a letter, I think. You could experiment and see if it works with a number or a underscore character. It can only have letters, numbers, and underscore characters in it, stuff like that. Probably got a limit on how long that can be. I've never run into it. Stating writing the fact that it returns no value. Now I'm up to, for the case of function that includes segments that are not self-explanatory. Okay, I thought there was one, I don't know that I'd call it a segment. It was just one line of code that might not be too obvious to somebody that, even though they know physics, unless they solve the problem or look at my pencil and paper. They shouldn't have to look at my pencil and paper to figure out what's going on here. Pencil and paper solution to the problem, or that part of the project. So there's one where I think it's a good idea to tell them, calculate when the car comes to rest. And then you got to provide attribution. So we only have one function, so this is our main function. And then say what you used here for what. Say what you used for what here. Use your own words, and don't be vague and brief. Say, oh, I used the videos to help write the code. Say what video you use for what if you use videos, or use the internet. Don't, put down the site that you visited. Give the URL for it, so that people can find out exactly what you did. For any case in which a function produces one or more graphs, hey, we get that. Each graph must be titled. Let's take a look at the graph the last time I had it. Title. Each axis must be titled with what is being plotted along the axis, and in square brackets, so not in parentheses, but square brackets, the units of what is being plotted along that axis. So, got that, and I got that. There must be an appropriate set of tick marks labeled with values. That comes up automatically. You'd actually have to work pretty hard to make those not appear. So, but it's covered, so we got that covered, and that's everything. So, just in case I made one last little, if I made any changes, let's run it one more time. Make sure it's saved too, I guess. So yep, I saved that. Save button is grayed out, and then alright, how about so plot, I go 5 comma minus 200, so huge acceleration. Shouldn't last very long, but yeah, look at that, 0.025 seconds. It came to rest in 25 milliseconds. Alright, let's go at a wrap for project 2, video number 3.